Data-driven approaches can be very useful, particularly when we have access to plenty of training data. But in some ways, purely data-driven approaches are naive since they rely solely on historical evidence to make predictions about likely future behavior. Ideally, we would also like to include in our predictions all the insights we have about driver behavior, physics, or vehicle dynamics. This is where model-based approaches can help. The way these approaches typically work is as follows. For each object, identify all the behaviors that object is likely to do in the current situation. A behavior for a vehicle could be something like change lanes, turn left, and for a pedestrian, it could be cross the street on pedestrian crossing. For our intersection scenario, the behaviors could be go straight, turn left, turn right. Whatever it is, it needs to be something that we can describe mathematically. Step 2. Define a process model for each behavior. A process model is a mathematical description of object motion for a behavior. It is a function which can be used to compute the state of the object at time t+1 from the state at time t. The process model must incorporate some uncertainty, which represents how much we trust our model. In our intersection example, the left turn process model would produce an uncertain future state located roughly here. The going straight process model would produce an uncertain future state located roughly here. And the right turn process model would produce an uncertain future state located roughly here. If you keep running the process models, your uncertainty will increase. Once we have a process model for each behavior, we can go to the next step. Step 3, which is to use the process models to compute the probability of each behavior. This is done by taking the observed state of the object at time t-1, running the process models to compute the expected state of the object at time t. Then, we compare the observed state of the object at time t with what our process models predicted, and we use a multimodal estimation algorithm to derive the probability of each maneuver. The purpose of these algorithms is to maintain some belief about how likely it is that the driver intends to perform each behavior. We'll go into more detail later, but in this case, the probability of going straight or turning left would be higher than the probability of turning right. The fourth and final step is to predict a trajectory for each behavior. This is done easily by iterating on the process models until the prediction horizon is reached. In the following videos, we talk more about the process models we use to model behaviors and then discuss one version of multimodal estimation algorithm that can be used to maintain beliefs.